Welcome everyone to another nightly open source benchmark video here with our Linux distribution. Today MIPS32R2, I believe, a MIPS creator board, later from Imagination Technologies, CI20, an Ingenic JZ4780 dual core, 2 GHz. It's running only, I believe there's maybe one missing, it's probably 1.2. MIPS32 processor with PowerVR, with spoiled and stuff. Floating point, 1 gig of memory, and the usual stuff versus latest and greatest MangoPie. D1, both with 1 gig of DRAM. D1C906 core, RISC-V, 1 GHz. As seen here previously and in the thumbnail. I'm running this already, I run this already, so don't need to bore you with those details. The results are also the state of our Linux distribution increasingly amazing, right? So I run, of course, T2, our run on everything cross-compiled Linux distributions that we maintain for 25 years. And this we can simply drop it on probably anything and the kitchen sink, or at least the fridge these days. So the results also, I'm really happy with the state of our Linux distribution, all right? The last years on YouTube, we made so much progress. Just YouTube warning, bandwidth, tell me if the video works. Also, just yesterday or so, yesterday or the day before yesterday, just recently I removed this, yesterday I believe, removed this recompression, right? This makes it so much snappier, right? So this is running here natively in the MangoPie D1 and CI20. And it's such a difference in if you build something that's not on our mirror, and you need to wait minutes for recompression. So the time's actually not that bad, and that also concludes how I will list this on our website. We list here hardware that we support and worked with over the last 20 years, and just last week started to add a performance index, just like this morning here for the desktop Apple Mac Pro 1.1 for our x86 testing efforts here. And so here performance index quite elaborative due to what we benchmarked. And so binutils obviously builds a while, right, on such a machine. Certainly don't want to wait 2 hours. We can, however, estimate this now. I believe this was relatively precise. So how amazing is all our new stuff? So the only thing is, let's hope we can somewhere. So I didn't run this in Tmux for, or did I? Yeah, I think I didn't. So somewhere there we are configuring, and there's the estimate. I think we are pretty close. So this was estimated 29 minutes. And I didn't build binutils, right? So this was estimated, reverse estimated from something like Lua or so. So our T2 estimation based on Lua, cross-reference, like reverse matching that to binutils, 29 minutes versus 26. I mean, if that is not good enough, then I don't know what is. And so for Bash, right, not binutils, and for the MangoPie, I believe, also I some reason didn't start Tmux there. That was, I believe, equally precise. And of course, we also didn't build, I probably built Lua also just for some reference time here to have an idea how much I can go for dinner and shopping, groceries and stuff. 21 minutes versus 14 maybe, or whatever is going on there. Plus minus, whatever, give or take, whatever package I built. Oh, by the way, maybe I used Lua JIT for one and Lua for that. Anyway, doesn't matter the most. The result is, we test here, of course, our Linux distribution. Why do I do this? I want to list this. I want to have some commonly known hardware here on our website. And I was still brainstorming how I should list this for the small board computers, because obviously binutils builds too long. We could guesstimate, let's scripts emerge, try run, deps none binutils. How much would it guesstimate? Yeah, 2.5 hours. And that is why, unlike Debian, we built this, we cross-compile this, right? I believe Debian has a whopping 10 or so, high five, sci-fi, unenriched. unmatched RISC-V boards for their native compilation, and we just cross-compiled it, right? I just literally cross-compiled a new MIPSL here, little Indian, before the live stream this afternoon, 2 hours, epics, we're ripping through that, right, with our cross-compile, nearly everything, setups here. It's simply amazing, right? I mean, leave in the comments below, share, like, subscribe, Patreon, or GitHub sponsorship. If that is not amazing, I don't know what is. And so yeah, for the Mango Pi, our build system currently would estimate 3.5 hours. Don't be disappointed, this is dual core versus single core, right? It's apples and oranges, MIPS, L and RISC-V. It's maybe not, I need to check what maybe this is the only MIPS cell board, MIPS little Indian. I could theoretically, maybe I have some ARM board from 10 years ago. But yeah, it's also, of course, not the state-of-the-art RISC. There are unmatched RISC-V. We have seen this previously. We played Doom and Quake on it. Previous video, I had RDNA running on this unmatched Sci-Fi board already over a year ago. Not epic thread ripping performance, but faster than this. And so this also means I build Lua, right? So the build time for Lua is just 3 minutes or so. Also, we built this, obviously T2 doesn't want to build it. So yeah, 4 minutes or whatever, maybe it was, yeah, around 4. Maybe it was 3 on the MIPSL here of force dry run of Lua. Yeah, 3 minutes versus 4 minutes. And again, this is 1.2. Actually, I would say this Mango Pi, for what it is actually quite fast. Of course, it's single issue, non-speculating and stuff, but it's just one single 1 gigahertz core, right? And for that, the MIPS, it actually kind of runs a circle, kind of nearly. It runs half a circle around the MIPSL board, as that is dual core, right? And clocking at 1.2 gigahertz, so that's actually quite respectable, only being 33% slower with 200 megahertz less clock and 1 core clock, one core less. So yeah, this makes it, of course, as I mentioned, so T2, not only we tested here for 4 years live on YouTube, implemented all kinds of stuff, everything that annoys me, I implemented now. Now we can really move on to microkernel. Of course, we will continue to polish. T2, I just updated further cache files with build time, relative build time estimates and dependencies. Still found some old ones. So for weeks I polished here some stuff, and now we will rebuild everything. The only thing is, of course, why you need to share, like, subscribe, Patreon, and GoFundMe and all this stuff, because there are some regressions. 2 months ago everything was building, and now there are some cargo build marginalities. The only constant is change and regression. So, and also uPower with whatever, and some Python, and sometimes, so yeah, our Linux distribution, due to upstream changes and people breaking their stuff, will keep us busy long before we will finish the microkernel. But it's so much better, believe me. Download it, give it a try. And yeah, I have also more stuff coming, right? Some more RISC-V stuff, and then we can, now that we can actually truly recommend our Linux distribution, and it's so much easier to use, right? We could just need to save the here. Maybe I should, before I talk, not to, so bash. So this is how we list this, right? So this is, of course, now I don't, the MQ Pro. So that is here, building, where did I have this already? MQ Pro. Where did I even, not to mix here something, so shell bash on the Mango Pi 2649. 2649 for this bash with, I believe, latest, this should be nearly latest, 13.1, okay, it's not, it's from last month, 13.10. I turned off LTO, I believe, and that is, did I save that already? Wait a second, this is Mango Pi, right? Did I? Because it is not the, is it the right kernel? What do we have there? I'm still running there. Oh no, I'm running our T2 kernel, of course. So yeah, actually I'm not sure what I copy and pasted there. Or maybe I didn't copy and paste it yet. So 6.1, Release candidate 3 for some. Alright, this was the MongoPy tree probably. Build. Oh yeah, this I spent some days of getting the kernel booting there, and now I remember what pain that was. And welcome everyone. Not try building Chromium, yeah, good. I mean, we will set up Chromium to cross-compile, right? Next big projects, of course, we will not run out of to-dos. I have 500 lines of to-dos, plus GitHub issues and other user wishes. So 2649, bash 52015, minecube bash 52015, GCC 13, there is, let's double check LTO. Or actually, no, wait a second, I rebuilt this. No, I take this back. I think I re-enabled LTO actually. I believe I had this built before I went to lunch. Let's double check that. Yeah, pro tip always double, oh no, it is off. Then I don't know what I remembered. LTO config. And yeah, we'll also need some script to automate this, to send it in automatically. Okay, did I not apparently, why did I, apparently I rebuilt this to 14. Ah, okay, so I probably changed that here, that was probably building. So no LTO, and then I don't need that buffer, and CI20, bash, no LTO, okay, probably I did that already, because I built that twice, probably with LTO. So yeah, that is LTO, so there you have it. That is LTO versus non-LTO on the CI20 Imagination Technologies, MIPS technologies. LTO, I believe, how should we document that? I believe I enabled smart, opt-in, default config, here, smart. You probably should document this like this. So this is O smart for this, or you can look this up in T2. So yeah, probably like that. And that was a smart, or what did I do there for opt smartest? Okay, yeah, a little bit. This was one was more default except LTO. I mean, we could rerun it with LTO though. Although I didn't really want it to stay that long. I mean, I could let it run overnight theoretically. LTO smartest. That was bash. No LTO. So what did I have now? Ah, smartest I had. So 2649. No LTO. Oh, smartest. I hope you find this useful. We will also eventually test SGI Octane. I'm really curious then. And also this is incidentally also didn't switch on my studio light bulb. You miss half of my LED light here. My recycled IKEA light bulb, where is a constant current source burned through. Yeah, it is ironically the same as Aleph Linux from scratch. They use for the version 1 bash and later binutils, and we always used binutils, and for we of course use always in our build systems, we use always binutils for build time reference, but then to document this, because I don't build stuff for 2 hours, right? You had me at the shit builds 2 hours like now. I wonder how long a 386 builds on this, or a Spark Station 2 40 megahertz. Previous video, probably if you like subscribe, probably we need to try that, right? You probably, I will probably not update the system on the Spark Station 2. I have a 7-year-old or something on that sort, because new kernel deleted that, new glibc deleted, no Linux thread support and stuff. And obviously it is hardly usable with 30-year later software. You can watch the boot log to scroll by. So yeah, it will probably be 2 hours. Like, comment below what's your guesstimate for a 386, 486, Spark Station 2, SG Octane, and Sun Ultra Spark. That's basically it for this video. Wanted to share this amazing stuff, and that everything builds now much better. We could check here with one more thing just for the, or should we LTO that, right? So with Did I document properly the optimization? That was, okay, smart, I probably documented that. We could test so if smart test works. And build something for fun like xterm with like missing only with our new much cleaner cache files. So this installation is some 2 or 3 years old. I can actually check. This is 20, yeah, it's, what did I say, 3 years old? It's nearly, also nearly spot on, 20 T226, right? I'm not reinstalling that for each and every, but it is the latest glibc and latest compiler. So it's a quite fair comparison, because basically the toolchain I reinstalled today because I have here only 2 or so gigabyte SD card in there, and my old test installation probably ran out of space. So I had to delete some files and reinstall. And also the compiler wasn't fully working for some strange reason. Maybe probably run out of space for installing. Anyway, so it's a fair comparison otherwise, because I updated glibc like to build today by T2, glibc, GCC, and MPFR, ISL, GMP or so. So yeah, I'm thrilled by my own Linux distribution, and I can tell you this is so much more fun. So xterm, okay, this is building some random shit though. I'm amazed, except when it builds random shit. That's not, why does it build open? So yeah, next is polishing emerge. So some strange stuff is pulling in there. Okay, is this, maybe the cache file is simply so freaking old. So let's see how long this builds for kicks and giggles. Yeah, maybe 4 minutes. Yeah, I probably pause the live stream. Those people who tune in new can rewind, and I quickly make a phone call, and then I report back in 5 minutes. And I guess that's enough testing for our amazing Linux distribution this weekend. Intel Xeon, MIPS, Little Onion, RISC-V64, Little Onion. What could you possibly want more? See you in some minutes for the build results. Both for the matrix to scroll by. Yeah, basically, and welcome everyone. Some quick 5 minutes, ask me anything. And that's also what we cross-compile this, right? Point me to someone who has a faster MIPSL machine, and so on, and certainly holding distributions like Debian back with delaying all the builds all that long. And of course we can't cross-compile everything, right? But that is upstream packages, maintainers, authors' fault. We do our best we can to fix everything. Probably next to somehow quirk glib. I'm aware that Open Embedded runs did I say glib? I mean G-object introspection. G-object introspection. Because it needs to run a tool to preprocessor sources. I need to check if we can somehow YOLO that. The Open Embedded people, the last time I've seen they run it through QEMU. The problem with that is that it's cumbersome and slow and error prone and doesn't support all architectures. So surely and obviously we want to build this for Itanium or other architectures that don't have a QEMU. And we will not port QEMU to Itanium, which probably once there was a half-working port or so. So yeah, one quick ask me anything. I find this really useful here. And by the way, we are not yet even making use of we are not auto-vectorizing to the Shuan TC906 vector extension or other CMove and whatnot things. So potentially there's even some headroom for that results to improve. So probably yeah, here we're waiting for results. That will be more of that bash with the same for LTO with the same Linux kernel. So let's see, it's how many 10% or whatever that is slower. And yeah, that's also what makes T2, right? Cross-compiling everything. That is such a blessing, except when it's a curse and we need to fix stuff to actually work. But wouldn't be so much fun if it wouldn't be for all the work we could do. So yeah, don't forget to subscribe, right? New stuff is coming. I mean, not only over the pandemic, I auctioned myself quite some nice vintage and historic pieces for my collection that we will program with, right? We will come back to microkernel, 3D programming. We will finish more S3 Verge and Voodoo 3D programming, then move on for our microkernel examples. This early stuff, because it's so much easier to program. I'm not writing a full Vulkan stack for my microkernel overnight. So we will start with simple stuff, or something also failed, but that might also be I mean, it could be out of space, might be something LTO wrapper failed for internal compiler errors. That is unfortunate. But maybe that it is possible that it is such an old installation. Did we just enable LTO? Not sure what we enabled here. Was LTO on? No, we built this. Okay, fine. This is here. This, as I said, this installation is 3 years old. Also, this is the wrong terminal. Var ADM logs of xterm. What is it? Okay, somehow, what is it even freaking? This is still in no, this is not in configure. What even did it do here? LTO wrapper failed. Not really sure what exactly it did here. Except internal compiler error segmentation fault. Out of memory? I don't know. Anyway, not the most important. Of course, the best thing would be not to run their stock example kernel. I've just never felt like spending a day or a week to update that. Theoretically, that is upstream in the meantime, maybe mostly working for the CI20. That probably next to nobody loved. Also, I didn't put more effort into that. I tested that with T2 proof of concept and had it ready and tested and supported it, right? Also, full disclosure, Imagination Technologies sent that to me some 5 or whatever years ago, right? For work on T2. And of course, I did write when companies send something, also a new RISC-V board. So also the Mango Pi was donated by a viewer. Thanks again, amazing stuff. Highly appreciate such donations because otherwise I have quite some stuff and I'm otherwise not really motivated to buy each and every embedded board. But when it's on my desk, I usually do something with it, like testing T2, because usually if we find something, also in this case, of course, spend a day on packaging kernel stuff to actually boot and yeah, the usual stuff. But more RISC-V coming, RISC-V of course being the future. Hopefully that next promised donation arrives sometime sooner. Then we do more high performance RISC-V stuff, which is amazing. Already looking forward to that and probably use it as a daily thin client, low power. Like, yeah, I mean, you can't even browse lightly on this, but like, yeah, remote thin client with native T2 testing. What other comments do we have there? The Graver quote is LFS stuff. That's what I meant, right? This is what I reiterated previously. Bash, now binutils. It incidentally matches. It makes sense for us because otherwise we base heavily on Bash, and in my opinion, the build time is still in reasonable. I mean, you don't want to daily, day long, day after day, and night and day benchmark that, but for one performance reference index thing, it is okay. Maybe I need to test. Maybe it is a good example for medium, low to medium performance machines to build as a first T2 package to get accurate. Actually, we could test that while we wait. Nothing better than more testing. This should be a pretty complete build from yesterday too, because obviously that's what we do daily here, building, fixing, and improving our Linux distribution. That is AMD64, latest and greatest virtualized epic thread gripping Ryzen. Probably I was tested, didn't I? Also probably mistyped it. Of course I mistyped it. This is probably installation from last night. And the fragmentation that it may bring along. It seems big silicon manufacturers are supporting it much more than ARM. I mean, the support is twofold, right? There are old vendors like NVIDIA and Intel who use it for their power management and other microcontroller design stuff because it's license free, right? Why pay ARM licenses for your Intel and CPU and GPUs and NVIDIA? So yeah, if it's free, it's of course preferable. Then there are pure CPU. There are not so many classic vendors, like not Intel and AMD, obviously switching because they have the x86 monopoly. But that are new vendors, right? Hi5, Sci5, this Alibaba subsidiary T-Head semiconductors and so on. Yeah, fragmentation is real. Fragmentation is a problem. Mostly, however, for like this T-Head, Alibaba T-Head semiconductor, Xuanxi, so because they implemented some not ratified incompatible extensions. That sucks a little bit more than it should. It's a little bit T-Head's fault. I mean, yeah, they shipped. I mean, you could. I mean, it works, right? Right now, I'm running only standard conformant code right now, which GCC auto generates. It's a little bit unfortunate. You lose some performance, and using the vector extension is tricky. It's like, yeah. I mean, but this is also something Intel and AMD would usually not have done, except once AMD had done that, there was once an AMD CPU that either I would need to. I mean, of course, nobody used it then, but AMD what was it, or like AMD CPU? There was some FMA3 or whatever. There was something, or also later, maybe the first Ryzen still had FMA whatever implemented, or whatever the case might be. Yeah, whatever, I would need to look it up. There were some things where either it wasn't advertised and partially working, and later it was advertised as not included, but still included and somewhat working. So it's not extremely unheard of, right? And also NEC, NEC of Nippon, also semiconductor stuff, did 8086 CPUs with probably NEC specific extensions, if I remember. So. And also, I mean, ARM is also completely convoluted with different floating point. So it's not like it never was. ARM is extremely fragmented with all the floating point extension 1, 2, 3, thumb and not thumb and thumb 2, and Neon and Neon 2, and now SVM scalable vector extensions 1 and 2. So it's like it's not really that much better in ARM, except there usually you didn't have CPUs with partially and half incompatibly implemented instructions. But I mean, you could simply ignore it. I mean, you could use those Xuanqi C906 and stuff, vector extension 07 previous video. You could manually do that. Maybe as the Chinese vendors, unfortunately, it looks like the high performance stuff will also have the same incompatible, not ratified vector extension. There apparently is some high multi-core, like hundreds of cores, high performance implementation in China that uses the same. So maybe there will be, due to that, maybe there will be more GCC support. But of course, it will generate code. Like if there ever will be more auto vectorization for that extension, non-ratified 07 draft. Yeah, I mean, but you could treat it similar to, it's just like MMX and 3D now, right? It's not like x86 never had that. So, but yeah, I mean, the other stuff will continue, but it's similar to x86, right? x86 has hundreds of extensions, not only 3, 4, 586, adding compare exchange, cmove, and different versions of NOP, long NOP and stuff, no operation instructions for Linux kernel using that for alternative patching. And then of course all the SSE, SSE2, SSE, whatever, and 3, and AVX 1 and 2 and 512, and now AVX 10. So plus all the previous video moment channel 20 or whatever, different CPU AD feature flags for all the different AVX 512 sub things that everywhere are partially implemented. So plus all the bit manipulation, all the other stuff like FMA 3 and 4. It's like, yeah, x86 is certainly the most complex mess, and yeah, probably eventually we will have the same with RISC-V, especially when vendor implement non-ratified plus their custom extensions. But it's not that bad. You don't usually need to use it, like maybe like rate accelerating, like think some storage vendor, maybe even Western Digital or QNAP or whatever, Synology or what their names might be, Seagate, implementing potentially some rate acceleration functions. You simply don't need to use it, right? It's like, so you can reverse engineer this or follow the documentation and stuff, but like, yeah, you just have some, or 3D GPU, right? There might be some domain specific graphic instructions. But mostly this will be, if there will be stuff like that, like think some next generation NVIDIA GPU or stuff using RISC-V potentially, maybe. If they have gazillions of NVIDIA specific 3D instructions, it's probably not that you would ever reverse engineer that, right? You would run the NVIDIA driver and so on, and that's it. So answering questions while we build for 25 minutes. So guesstimate also like testing. Oh, of course, this is a win-win, right? I constantly improve T2. We test stuff. I might certainly need to reinstall that also with a bigger SD card. It's like, yeah, it's a little bit more than, it's like, yeah, I mean, this was some ballpark. Wait, this is faster? How can this be faster? Ah, okay, this was, wait, which, how is this faster? That is, I mean, maybe stuff is more cached. This is bizarre. We did we build? I should have checked. What did we build previously? Did I start btop maybe? Did this go anywhere? What do we have here? Insert others dash O. Where are we? O fast. So hot O fast. So O1 O fast. So 1 O fast. Okay, well, let's better check our sources. Package gcc parse config smartest. So should have been smartest. How is LTO faster? That is bizarre. Should I even? I mean, documenting. Okay, if it's not really different, why document it? Can it be that much more cached? That is bizarre. Oh, actually, can LTO be faster? That is interesting. So, because all the individual files are compiled faster, not optimized to internal bytecode, or no, not even bytecode, internal IR, intermediate representation. That is bizarre. I totally didn't expect that. I mean, should I leave it here? Or, I mean, that doesn't really hurt someone, right? Wow, that is interesting. I mean, maybe it's not always true for stuff like Firefox, where then the LTO stuff links for 6 minutes or whatever. But that is a bizarre find and truly interesting. Totally, yeah, the more you benchmark, the more, like, don't trust the benchmark you didn't fake yourself. So, yeah, interesting, truly interesting. Also, we probably don't need a line break here. Let's put that there just for, why not? And also here, why not? And what do we have here? So LTO, non-LTO, LTO. So here it probably was indeed, like, yeah, maybe we list in this order because why not? It's first of reasons. Yeah. Anyway, that's this compiler errors might be whatever. It's not the latest. It might go away if we build. What was even? Did I change? We did build with. I probably should check that. So that was. You know what? Do I have btop on? Just for fun. Emerge. No, we don't. I have this already. Btop. I believe I emerged that. That built 48 minutes. Yeah, this built 48 minutes. So, yeah, there is it. And this is, yeah, C++ is like modern C++. Good luck. Goodbye and good luck. I don't have it here, so. But yeah, on the Raspberry Pi Zero, it also built 35 minutes or so. I might not have documented. Where's my Raspberry Pi Zero? Where's my Raspberry Pi Zero? Maybe my home office. Anyway, so that's documented. Did I check this log here of, what was it? This was bash. Yeah, leave in the comments what you want to see next. SG Octane, Sun Ultra Spark, Hewlett Packard Precision Architecture. So dash, also that is OS hot 02, so that, yeah, that is smart. Smart, so yeah, non-LTO probably, yes, this is also O. Did I not had, I do not have O smart here. Or was it not O smart? Did I had fixed, what did I had previously there? Okay, you know what, maybe I don't, what do we have here? What did I know? Okay, let's maybe not document it because now I'm not sure anymore which. It's fine. LTO smart is that. Also mileage may. Wait, what did I say? Did I not? Oh, was it with? Here it was. I lost overview. Did I not delete one? 25. Did I say I leave it there? No LTO smartest. Yeah. Just here, I'm not so sure what we built previously. I obviously don't have the log anymore. Okay, let's only document the ones that we truly know. So we truly know we built LTO smart in 1420. And yeah, that is, if you don't automate it then and talk while you do this stuff, then 1421. So yeah, the times are independent, so that's 1 second off because the yeah, interesting, must just flipped over there because it prints on the screen independently. What else do we have there? Testing new MDPU scaling driver. What's your opinion on Rust programming language? I said this a couple of times already, sort of. Will it take over C? Probably not, but it's a long story. I told you before, I probably need to make a dedicated video so that I can point you always. It makes no sense to repeat it the 5th time. It's in the middle of some live stream. Share, like, subscribe. I will make a video dedicated to 10-minute my opinion to Rust. My opinion about Rust. Carlos, never heard about Imagination CI20. Is this board available to buy? It was available to buy. It's already some. When was it released? CI MIPS. It's already nearly 10 years old. Or not 10. Is it only 5 years old? Maybe it's only 5 years old. Maybe you still find stock somewhere. I mean, it's not that super old. I released it 2014. But I didn't, yeah, whenever. Maybe I got it in 2015. So yeah, I just got it probably before I started the YouTube channel here. So maybe you find still new old stock or other used sales somewhere. We could quickly, which we emerged xterm, right? Xterm force. What does that rebuild? Okay, our xterm is apparently indeed strange. Let's rebuild this. Depths none. It might be one of those occurrences where our depths are still. Maybe this is still super old. Yeah, we did what we wanted to do. Shut down this, and so this is change rooted. So shut down, because I never bothered to install this natively. Because why should I waste my time with that? So that is shutting down. That was xterm on the Ryzen VM. Yeah, there was open. It's not that old. For some strange reason, there was open LDAP in there. That is, of course, interesting. Good that we find this. I mean, obviously, this will not creep in there because I now carefully review all the depths we add. So that is adding some. I mean, maybe it was some created header or stuff like that. That's not. I mean, usually I'm good at spotting that, but I must have some overlook. Not sure if libgsf is that really a dependency or is it some stray nonsense. And I will continue to clean this up, right? Was it GSF or whatever? Yeah, man, okay, that is one. So yeah, we will further each time, we will create further filtering and automations. Was it libgsf? Probably it was, huh? We will further make sure that in the future this will not be a case anymore. See any other stray stuff? libxo also. Why is this something optxfce? What has it to do with? What was it? Exo stuff? Okay, yeah. In the future, we are close. It will become even more perfect. And another small win, right? It's not super important, but this kind of things are of course annoying, and that makes or breaks a project, right? And you see 4+ years live on YouTube. This is here if you want to know how much work it is to maintain, create, maintain, and support a Linux distribution. This is how, and this doesn't even include marketing because our marketing so far in 20 years was next to non-existent, but this will change now. Next, kicking up marketing and overdrive for more, so that is here, I'm cabling this. So yeah, also if you want to contribute, like if you can't donate because student or so, or otherwise, you can just do some marketing, right? Share, like, subscribe, post our stuff somewhere. Okay, precious. Can I have too many adapters? Precious mini HDMI. Let's clean up the office a little bit. What's a keyboard? It goes there. It's another dongle, right? You can have enough dongles to test your embedded boards. Where is now my... Where do I have now the... Ah, here. Nothing like... So yeah, that's it for this video. Small wins here and there, but yeah, this is what makes a Linux distribution successful, right? When everything just works, just like on next step. And yeah, it's a pity. I could kind of release now. If there were not, like, if we rebuild everything now, it will probably take some more days. Just because upstream regressions, right? Cargo breaks somehow, and some Python and Perl details somehow, and that is an annoying thing. Somehow, always, you know, there's my rubber band. Somehow, where's this band? Oh, here was some rubber band holding the Mango Pie box together. Maybe I find it tomorrow on the floor. Here. That is the difference. I wish I would know where this rubber is, but somehow it disappeared. That's it for this video. You don't need to watch me sort my desk. Dongles and cables and adapters. And USB sticks. What is this? This is my precious. This is a mini ZAS. Previous video, mini ZAS connector cover, plastic cover thing. Hope you enjoyed this and learned something. Don't forget to share, like, and subscribe. And I hope to see you soon for the next videos. Code and reviews to come. Where is this rubber band thing? Why do they always disappear live on YouTube? Yeah. Have a good day.